Hello guys, today we are gonna solve a question from the chapter integral functions, and let us see what do we have. We have to integrate a function that is sin x upon 1 plus cos x raised to the power 2, and we have to integrate with this function with respect to x. So you can see that our numerator is the exact differential of the denominator. That is, if we differentiate our denominator with respect to x, we get numerator. So what do we do when we satisfy this condition? We simply assume our denominator or the part of the denominator as t, whichever is deemed fit. So now let us see the first step. Yeah, that is it. We assume 1 plus cos x is equal to t, then we differentiate it on the both sides with respect to x, and we get minus of sin x cos x dx, minus of sin x dx is equal to dt. Now we make two substitutions, these two substitutions in the original function. So what do we get after substitution? We get a final integrand as minus dt upon t square. Now this is a pretty straightforward integral, and that is 1 upon t plus c. After we integrate it, we get 1 upon t plus c. But before writing a final answer, we need to back substitute rt. That is, we need to t in the terms of our original variable, that is x. Now moving to the next slide, we get 1 upon 1 plus cos x plus c as our final answer, where c is any constant value. So that is it. I hope you all got it. Thank you. Have a nice day.